Good morning. Welcome to the next session of torque measurement. In the last class, we discussed about classification of dynamometers, construction, working and applications of different mechanical dynamometers. In this class, we discuss about hydraulic and electrical dynamometers. Let's start with hydraulic dynamometer. It operates on water brake principle using fluid friction rather than dry friction. In construction, it consists of a rotor, which is shown red in color, and it is keyed to the engine shaft. And on both sides of the rotor, we have got stators, and these stators are fixed on a housing. On both rotor and housing, we have got grooves like this, and the grooves are known as semi-elliptical grooves, or otherwise known as toroidal pockets. And water is admitted into these semi-elliptical grooves through an inlet pipe, and the water is taken out from these chambers from an outlet pipe. There is an arrangement for measuring the RPM of the rotor, and also an arm is fixed over the housing, and in this arm either we are adding weights to balance the movement of the stator, or we will have a torque meter to directly measure the torque. And in working, when the water is admitted into the toroidal pockets, it will have a rotary movement like this in this direction. So it will get rotated into this toroidal pocket created by both rotor and the stator. But the rotor is also rotating along with the engine shaft. So both the rotary motions, that is the rotation of the rotor and the rotary motion of the water, will have a combined effect, and that is shown in this figure. That is, once the rotor is moving in this direction and the water is spiraling like this, so the water, so this figure is giving the path of water flow, and this path of water flow is given as vortices, known as vortices. Because of this vortex movement of this fluid will exert a force on the stator, and it will tend the stator to move along with the rotor. But the motor movement is restricted by an arm, and this arm we are adding weight to restrict this movement, or otherwise we are measuring the torque using a torque meter. If we are adding weight to restrict the movement of the stator, then the power P is given by the equation Wn divided by K, where W is the added weight, N is the RPM, and K is known as the dynamometer constant. These hydraulic dynamometers are used to measure power up to 20 kilowatt and speed up to 10,000 RPM. And in the advantage part, it is used for high power measurement and high speed. Then water supply serves two purposes, that is providing braking action and cooling. Then high absorption capacity in small space and low cost. Next is eddy current dynamometer. So the eddy current dynamometer is a kind of electrical dynamometer. So first we will see what is eddy current. So eddy current is otherwise known as localized current. So we will consider a metal tube like this. It's a hollow pipe, and if we are using a magnet like this. So it will have magnetic fluxes like this, and we will move this magnet inside the pipe. Then what will happen, if by moving of this magnet inside the pipe, it will have small current will be induced on the surface of this pipe. That is a localized current, or otherwise known as eddy current. So this eddy current is always producing again its own magnetic field. So it will have magnetic fields. So this eddy currents are producing magnetic field, and this magnetic field is actually opposing the movement of this magnet. That is the principle we are using in eddy current dynamometer. Let's discuss the construction of eddy current dynamometer. So it contains a steel toothed rotor which is fixed to the shaft of the engine, and above that rotor we will have a cast iron stator, or otherwise a housing, and on the housing we have got exciting coils placed around the periphery inside of the stator, and this exciting coil is nothing but electromagnets excited with the external supply, and we have got the cooling water arrangement to carry away the heat produced by this dynamometer. When the rotor is rotated along with the engine and the exciting coil is excited, an eddy current is formed like this. Since the eddy current is opposing the rotation of the rotor, it will tend to rotate the stator. The rotation of the stator is prevented by an arm, and on the arm either we will have a weight loading arrangement to prevent that rotation, or otherwise that will be connected to a strain gauge to measure the torque directly. This figure shows the general arrangement of an eddy current dynamometer. So this one is the drive shaft, and the drive shaft is connected to the rotor, and over the rotor we have got the stator, and on the stator we have got excitation coils, and it has got an arm like this, and on the arm a strain gauge is fitted to measure the torque directly. The range and speed of eddy current dynamometer is given as it is suitable to measure power up to 250 kilowatt and speed up to 6000 rpm, and in advantage this one is smaller in size for a given capacity, suitable for large speed range, and good control at low rotating speed. By this we are concluding the torque measurement topic. Thank you for watching and stay safe.